Okay, so once again, a warm welcome to everybody who have assembled over here for the great new event known as Ease the Quants, which is a quantitative aptitude enhancement event, which is organized by the Leo Club of CEG. So I would give a warm welcome to all of you and good evening to all of you. Since it is 7:07 and a couple of people have joined and the recording has started, let us start our session now. I will be sharing my screen now. I would suggest everybody to keep a paper or a writing pad along with a pen with them so that because this is a quantitative aptitude session and not a history or geography class. So here the things should be done practically and the hand should be keep on moving. So you should keep on writing the formulae or the concepts, whatever you understood, and then you try to apply that in the questions. So let us actually discuss the concepts related to time and work. So time and work is going to be a very, very important concept, a very important chapter. In the textbook of R.S. Agarwal, it is divided into three chapters. Chapter number 15, chapter number 16, and chapter number 17. So it also includes the applications of time and work, that is chain rule, unitary method, and pipes and systems. So this concept is going to be very important because right from the clerical level exams to any MAT or CAT or any other great exams, the time and work always has one or two questions present in the quantitative aptitude section. So this is a very important topic. Actually, it is dealt for the small children in 8th and 9th standards, and that is also asked in the employment level exams, even in the placement level exams like TCS, Ninja, Infosys, and many other core companies also tend to ask these kind of aptitude based questions based on time and work, because aptitude is a very important part of the career point of view. So let us take a deep dive into the time and work concept today. So today I will be dealing time and work concept into three parts. The three parts is going to be, part A is going to be your chain rule, that is chapter number 15 according to R.S. Agarwal book. And the part B, that would be the unitary method, that is going to be the real time and work concept. Then part C is nothing but an application of time and work, that is going to be using the negative efficiency approach, which I will be dealing later. And that is going to be the pipes and systems approach. So that is also very important questions that is asked in many of the state government exams as well as central government exams. So on the whole, this is a very important chapter, I could say. So let us take a deep dive into it. So actually, firstly, I would like to discuss the important formulae, the important concepts, and the TSRs. What are these TSRs? Time saving results, because these competitive exams are such that you have to answer everything in a very fraction of a second. For example, you just need to answer a simple question in 1 minute or 1.5 minutes. So these time saving results, they will help you to reduce steps. And moreover, in such competitive exams, and this is of course known to people who have written the NEET exam, especially the physics part of NEET exam. They will not have space to write to solve the questions. So they can't keep on writing the formula and the steps and other things. So many things they have to remember. So these time saving results will help them a lot in that. So firstly, let me start from the basics. So because the building is going to be strong only if the basement is going to be strong. So let me start from the basics. So first, as you can see the screen, I hope the screen is visible. Direct proportion. Now, what do you mean by direct proportion? If A and B are in direct proportion, then if with the increase of A, there is going to be increase of B. And with the decrease of A, there is going to be a decrease of B. A and B are directly varying. For example, let us take an example from the commerce section. Cost is going to be directly proportional to the number of articles. If number of articles is more, then cost is more. So that is the case. Now, next is the indirect proportion. Indirect proportion means if A and B are in indirect proportion, that means with the increase of A, there is going to be a decrease in B and vice versa. So now what is an example of an indirect proportion? I hope in the 12th standard, no, you must have studied 12th and 11th standard, you must have studied the Boyle's law in chemistry. PV is equal to constant. The pressure is inversely proportional to volume. Similarly, current is inversely proportional to resistance. With increase of resistance, current is going to decrease. So these are examples of indirect proportions or inverse proportions. So I will be telling the commerce related examples later in the next pages. Let us move on. I hope the direct and indirect proportion is understood very well to all of you. You could please make a note of it if you want. So let me proceed. I hope the slide is changing. This is the main formula for the time saving result for chain rule. Actually, many people explain in different ways, but this time saving result is going to be a brahmastra, I could say. You could just finish the problem within seconds if you know the different variables present in the question paper. If you could figure out the different variables present, so you could take down the formula displayed on the screen. I hope, let me just make it a little bigger so that it would be better for you to take down the formula. M1 D1 H1 by W1 is equal to M2 D2 H2 by W2. Now, what is this formula signifying? M1. M1 is nothing but the resource, or man or woman. They will say 13 men or 14 women or something like that. So that is going to be your case 1 on the left hand side and case 2 on the right hand side. So M1 is the resource, man, woman, boy, girl. So all these contents to M1. D1 is how many days they are working. They work for 4 days. They work for 5 days. So that is D1. H1 is per day how many hours they are working. So they are working for 6 hours per day, 8 hours per day. So you have to substitute H1 as 6 or 8. Then you have W1. W1 is the amount of work. This will come only when the case 1 and case 2 are related. So now similarly, M2, D2, H2 are nothing but the resources, days and hours of work in the second case. Now what is the difference is H or W1 and W2? Now if you case 1 and case 2, if they are doing the same work, W1 equal to W2 equal to W, you can just cancel out the W's. They might say in the case 2, they are going to work twice as that of the case 1. So you have to substitute W2 is equal to 2 times W1. So these are some of the important things that may arise in the question paper. So you have to use this formula. Please keep this formula in your fingertips, because this is a very important formula, a very time saving result, I could say. M1 D1 H1 by W1 is equal to M2 D2 H2 by W2. Let us see some problems. I hope, yeah, there is another concept known as the man days concept. So where M1, D1, H1 by W1. Now, H and W are going to be same in case 1 and case 2. This is nothing but a special concept of the previous formula. M1, D1 is equal to M2, D2. This is an example of indirect proportion. That means number of days worked is indirectly proportional to the number of men working. If more men are working, less number of days are required to complete the work fastly. If less number of men are working, then you require more days to complete the entire work. So M1 D1 is equal to M2 D2 is another very powerful formula that could be used in many of the competitive exams to solve the chain rule related questions, where M1, M2 are the number of resources, men, women, boy, girl in case 1, case 2 respectively. D1, D2 are the number of days they work respectively. I hope the chain rule formula and the man days concept, which is a we could say specific derivation, where M1 D1 H1 by W1, H1 and W1 are going to be same in both cases. So next one, as I had mentioned about in the first page, about direct proportion and indirect proportion. Let us see, first two examples are examples of direct proportion. So as mentioned before, cost is directly proportional to the number of articles. Now if you buy 1 cup, that 1 cup is going to cost you X rupees. If you buy 2 cups, it is going to cost you 2X rupees. So cost is directly proportional to number of men. Next, work is directly proportional to number of men. Sorry, cost is directly proportional to number of articles. Work is directly proportional to number of men. That is, if one person is there, he is able to do only 1/12 of the work. But if 2 people are there, he is able to do more work. If 100 people are there, they are able to do more work than the work done by 2 people. Now let us see examples for indirect proportion or inverse proportion. Time is inversely proportional to speed. If speed is more, he is going to reach the place in lesser time. If he is going on a lesser speed, then he is going to take more time. I think this analogy is going to be very natural and very much understood to people. And the fourth analogy is time to finish the work is inversely proportional to number of workers. That is also mentioned before itself. If workers are more, easily within less amount of time, they are able to finish the entire work. But if number of workers are more, they are able, that is if number of workers are more, they are able to finish the work in less time. If number of workers are less, they are able to finish the work in more time only. I hope the analogy of direct and indirect proportion, the chain rule concept, and a specific derivation of chain rule concept, that is man days concept, is very, very clear to all of you, because this is a very, very important part as well as as far as the competitive exams and placement exams are concerned. Let us see some examples based on these concepts. Please understand the concept behind the formula, and then only you could remember the formula and implement it in the right time. So let me give a very easy and a very basic example. This has appeared in many competitive exams. This is also from the RS Agarwal MCQs. So 54 men take 15 days to complete a work, working for 6 hours a day. How many hours a day should 30 men work to complete the same work in 27 days? Now your pen or pencil should be very clear to jot down the points. You should just underline in the question paper. 54 men is just M1 right above it. 15 days is D1 and 6 hours per day is H1. How many hours? They're asking H2. Put a question mark above that. 30 men. M2 is 30 men. Please underline that. 27 days. They're able to complete the work in 27 days. So D2 is 27 days. And you have to importantly note one main concept that has been highlighted in red ink. Same work. Same work means W1 equal to W2. Now upon substituting in the chain rule, M1 D1 H1 by W1 is equal to M2 D2 H2 by W2. Now please substitute 54 for M1, 15 for D1, 6 for H1, and H2 is to be found out. M2 is going to be 30 and D2 is 27. And it has been mentioned same work. That means W1 equal to W2. Now upon simplification, you can able to get the answer as 6 hours. I hope it is understood. So this is a very, very perfect and very, very strong formula that can be used to solve such kind of problems where they are giving two cases. Now, I am going to give you another problem. Let me just switch on to the next page. I will write the given data also. 24 men take 20 days to complete a piece of work. In how many days 15 men can complete the same work? So they have given M1 as 24, D1 as 20, M2. M2 is what? M2 is 15 men. And how many days? So D2 is asked. D2 is your unknown. So now you please apply the man days concept and please find out what is D2. On application of man days concept, M1 D1 is equal to M2 D2. So what is given? M1 is given as 24, D1 is given as 20, M2 is given as 15, and D2 is they are asking how many days you have to write to find. So you don't have to write the given data. This is not a public exam where you have to write given and formula, everything. So this is going to be a competitive exam. So what you have to do is in the question paper, you have to underline above M1, you write it, above 24, you write M1, above 20, you write D1, above 15, you can write as M2, and D2 is supposed to be found out. And of course, if it is a computer-based test, CBT, you could just jot down somewhere in the piece of papers. And I also have experience that they don't give more amount of papers, especially in competitive exams, because paper is going to be a constraint. Paper is going to determine the first rank and the second rank. So that is also a very important thing. So you have to do many amount of mental calculations and mind works, and that is why the TSRs are very, very important for you. So M1 D1 is equal to M2 D2, and we found out the D2 as 32 days. We could just mark it as one of the option. So I hope the man days concept is also very clear. So let us move on to the third question. This is also an exam. This is also a trial question. Please, fastest fingers. So take down the data and work out as per the given concept. That is the chain rule concept. So it is given that you could also please you go on telling the answers in the chat box. Okay, let it be a continuous process. A piece of work can be completed by 18 men. When you see 18 men in 12 days, in 6 hours per day, mark M1, D1, H1 in the question paper. Then they are asking how many men. So M2 is the unknown variable. Put a question mark above it. Are required to complete the same work is not given. I have just scratched it out. I have written in bold. How many men are needed to complete another work which is twice as great. So twice as great, that is work 2 is twice as great as work 1. That means W2 is twice as great as W1. In 9 days, D2 is 9. 8 hours is H2. Now what is supposed to be found out? M2 is supposed to be found out. So of course, as mentioned before, M1 D1 H1 by W1 is equal to M2 D2 H2 by W2. And now upon substituting M1 as 18, D1 as 12, H1 as 6, M2 as, no, that is to be found out, D2 as 9, and H2, we can find out the required parameter. So this is also another example. This is also using the man days concept. X men can do work in 120 days. If there were 20 men less, then work would be done in 60 days more. Now you want to find X. So man days concept is supposed to be used. So M1 is supposed to be your X value. So that is to be found out. And D1 is given as 120 days. Now what is M2? They have given 20 men less than case 1. Case 1 is X. Case 2 is X minus 20. Next, D2. D2 is what? 60 days more. In first case, 120 days. 60 days more means 120 plus 60, 180. Now, upon application of the formula, M1 D1 is equal to M2 D2. X into 120 is equal to X minus 20 into 180. Now you can go to the 60 table. 62s are 120, 63s are 180. Upon cancellation, upon simplification, we are able to get the answer as 60. X is equal to 60. So this is also using the man days concept. M1 D1 is equal to M2 D2. You could get the value of X as 60. And this would be one of the options. Just tick it out. Next, I hope the man days concept and chain rule is very well understood to you and you could grasp it very easily. So this is another very important concept or very important question which is asked in many of the competitive exams as well as many of the different placement exams. Let us see that. They have given different genders or different variables they have given. 3 men or circle that or 4 women can construct a wall in 62 days. How long it will take for 12 men and circle that and 15 women to do the same work? As mentioned there, the hint is convert all variables to a single variable. Either you convert every man to a woman or you convert every woman to a man. So now 3 men or 4 women do the same work in 62 days. That means their power is equal. 3 men is equal to 4 women. So 1 man is equal to what? 4 by 3 women. This is example of unitary method which I will be dealing in the further PDF. So 3 men is going to do 4 women work. Then 1 man is equal to 4 by 3 women. So I hope this analogy is understood. So let us calculate the number of people in case 2. The case 2 number of people is 12 men. So instead of M, you substitute as 4 by 3 women. So 1 man is 4 by 3 women. That is computed by us in the previous step. So you calculate the number of people in case 2 as 12 into 12 men. So 12 into 4 by 3 women plus 15 women. Women is equal to women. So 1 is equal to 1. That is not an issue. 15 women. So now upon cancellation, 3 4s are 12, 4 4s are 16. 16 plus 15 is 31 women. Now what is the thing is, now you have to use your man days concept. Man days concept is nothing but M1 D1 is equal to M2 D2. M1, now you are considering everything in the terms of women. So 4 women. They are able to construct the wall in 62 days. D1 is 62. 4 into 62 is equal to number of people, number of women in the case 2 is 31 women. 31 into how many days they are going to do the same? D2. So 4 into 62 is equal to 31 into D2. 31 2s are 62. 4 into 2, 8 days. So 8 days is taken by 12 men plus 15 women. Both of them together, they're doing the work. They complete the work in 8 days. So there are 3 categories over here. So main hint is convert everything to a single category. Okay. So that is going to be our main hint. 8 men or circle that or 12 women or circle that another or 20 boys. They complete one particular work in 36 days. So 8 men, they're able to complete the work in 36 days. Or 12 women alone, they're able to complete the work in 36 days. Or 20 boys alone, they're able to complete the work in 36 days. Finish. That is case 1. Now in how many days? 6 men and 10 boys and 12 women. And means plus plus. This is not electronics where and is multiplication and R is addition. That is different. This is the time and work concept. 6 men and 10 boys and 12 women means you have to add everything. How many days they take to finish the work? So first you convert everything to a single variable and then use the man days concept to evaluate what is the unknown parameter. So let us see. 8 men is equal to 12 women is equal to 20 boys because they are having the same ability. So using the unitary method, 1 man is equal to 20 by 8 boys. 1 woman is 20 by 12 boys. 1 boy is 1 boy. So especially we tend to convert men and women in the terms of boys because simplification tends to be easier. Now in case 2, we have to calculate the number of people. Number of people is going to be 6M plus 10B plus 12W. M is men, B is boys, W is women. So 6M plus 10B plus 12W is the number of people in case 2. So 6 into what is men? What is the 1M is equal to 20 by 8B. 1 woman is 20 by 12B. So 12 into 20 by 12. And 6 into 20 by 8. And boy is boy. So 10 boy remains as it is. Now upon simplification, now 12 can be cancelled, and 26 or 120 by 8 also can be cancelled. So we get the number of people in terms of boys in the second case to be 45 boys. I hope the computation is going to be very clear. Now, as mentioned in the before problem, now just take up the man days concept. M1 D1 is equal to M2 D2. Now, boys days concept, because we are considering both sides the same variable. Especially in I think +1 science, +1 physics, there's going to be a principle of homogeneity that commands that both sides LHS and RHS, it should be same unit. That is, if liter is there, this side also liter should be there. Liter cannot be equated to kg. Liter cannot be equated to Newton. So both sides boys should be present. So B1 D1 is equal to B2 D2. B1 is first case is 20 into 36 days, that is D1. And B2 is 45 boys, that is computed in how many days? And upon computation, 20 into 36 by 45, you are getting 16 days. So that is going to be the answer. For 16 days is consumed by 6 men plus 10 boys plus 12 women. All together work, they complete the work in 16 days. Let us see one more question. You can work it out. Yes, I think we could proceed to the unitary method. Hope this concept is finished, because hope this concept is very much understood, because this is a very important and interesting concept, and they tend to ask these such questions to test our knowledge. So we have to be very careful, and you should always know that both the sides of the LHS and RHS, same quantity should be present. That is, boys, boys, women, women, men, men. You should not equate men with boys. It won't be, you won't get the right answer. You should be very, very careful in that. In what happens is, when we are in the tense mode in the exam hall, no, we tend to commit such mistakes. So such mistakes should be avoided. Okay. So next one is our unitary method. So unitary method is a very important and very easy concept. Unitary method is nothing but very easy. Total work done is 1. The crux concept is total work done is 1. That is a unitary method, means total work done is 1. So in the R.S. Agarwal, the CDF has been given as if A can do a piece of work in n days, then what is 1 day's work of A? A can do a piece of work in n days, then 1 day's work of A is 1 by n, because the entire work is considered to be 1. So 1 day's work is divided by n. And similarly, converse is also true. If 1 day's work is 1 by n, then total work is 1, and he can complete the work in n days. So the statement mentioned on the PDF as well as the converse is very much true, and this is to be used. And even note the second point, efficiency inversely proportional to time taken. How efficient you are is a measure of how less time you complete the work very easily. And you should also note a very important point that would come in the later slides. Salary in an institution or an industry is distributed only on the basis of efficiency. It is not on the basis of time taken. He worked for 100 days, I'm going to give 100 days salary. No. Salary is given only for the efficiency with which the person is working. So you could understand it in the more examples that would be presented in the before. So let us take an example. A is thrice as good as B. So ratio of work done, ratio of efficiency is 3:1. But ratio of time taken by them is 1:3, because efficiency is inversely proportional to time taken. So let us see some examples. So A does work for 15 days. Okay, the question is given as A does work for 15 days and completes it. That is, A alone can do the work in 15 days. B alone can do the work in 20 days. So please note it down. A alone can do the work in 15 days. B alone can do the work in 20 days. Both of them start together. Okay, they have to work together. That is the commitment. So first, what is the thing is, A left after 8 days. 8 days A has worked and he has left. Now B has to come and work. In how many days B would take to complete the work then? I hope the scenario is understood to you. Hope the scenario is understood to you. A alone does the work in 15 days. B alone does the work in 20 days. A left after 8 days. Now we have to compute how much work A has done in 8 days. So as per unitary method, let us take A's alone criteria. A alone completes the work in 15 days. Okay. So to complete the entire work, he takes 15 days. Now to complete 1 day's work, how much work percent or how much fraction of the work he completes in 1 day? It is 1 by 15. Example, how much work he does in 5 days? 5 by 15. How much work he does in 8 days? 8 by 15. I hope it is understood. 1 day's work is 1 by 15. 8 days work is 8 by 15. We assume the total work is 1. This is similar to probability. Probability also total probability is 1. Here total work is assumed to be 1. So A has done 8 by 15th part of the work. How much is left? 1 minus 8 by 15. Total work minus how much work A has done is going to give how much work B has to complete in these remaining days. So 1 minus 8 by 15 is going to result in 7 by 15. That is the resulting work. How much work is pending? How much work B has to do? And what is B's capacity? He can complete 1 day's work. He could complete the one work in 20 days. 7 by 15 work, how much days he will complete? Using the unitary method, 7 by 15 into 20. Upon multiplication and other things, simplification, you get it as 28 by 3 days or 9, 1 by 3 days. Always options are present in the form of mixed fractions. A's capacity is 15 days. He could complete one work. So 1 day's work of A is 1 by 15. 8 days work of A is 8 by 15. Remaining work is 1 minus 8 by 15, that is 7 by 15. 7 by 1 work is completed in 20 days. 7 by 15 work is completed in 7 by 15 into 20 days, that you are getting as 28 by 3 days. Hope it is understood. Now let us move on. Okay, there are two examples. Hope all of you are concentrating. Let us see the 8th question. A alone, what is A's capability? He can do that complete work, one work in 8 days. Whereas B, he can do the complete work in 12 days. B started. After B started, he worked for 6 days and then he left. Now A will complete he will do the complete work, or he will finish the work in how many days they have asked. They would have given 4 options. So now what is to be done is immediately B started up. So you have to compute B's work. How much work B has completed and he has left. So let us take B's parameters. B completes one work in 12 days. B completes total work in 12 days. Both are same statements. Please note it. Because total work is assumed to be 1 in this method. B completes one work in 12 days. So what is 1 day's how much work he has done is 1 by 12. He worked for 6 days. 6 by 12. What is 6 by 12? 1 by 2. Half work he has done. So remaining half work is pending. So now A has to come and he has to work in the factory. A will finish one work in 8 days. Correct? Half work, how many days will he finish? 8 by 2, 4 days. So he takes 4 days to complete the work. So I hope this is understood. So you should write down the answer. You should just tick the option as 4. A finishes the work in 4 days. Now let us take the 9th example. This is a little different. I would like you to jot down the points and work simultaneously to find the X value over here. So what is A's capability? 15 days. I hope the screen is visible and everything on the screen is very clear. A capability is to finish one work in 15 days. B capability is finish that one work in X days. Okay. Now A has worked for 12 days and that fellow left. Now B has to come. He has to finish the work in 8 days. So that project manager is telling you have to finish the work in 8 days. Then you have to find out the capability of B. How many days he is able to complete the one work, or how many days he is able to complete the total work. So let us calculate. So A has worked first and he left arm. So let us take A's capabilities, one work he is able to complete in 15 days. So let us take 1 day's work of A is 1 by 15. 12 days work of A is 12 by 15. 3 stable, 4 by 5. So 4 by 5th of the work is completed. Now total work is 1. How much work is pending? 1 minus 4 by 5, that is 1 by 5. So 1/5 of the work is pending and 1/5 of the work is completed by B in 8 days upon the guidance of his project manager. Now, what should be the capability of B so that he is able to do this task very greatly and he is getting good compliments from his manager? So he is completing 1/5 of the work in 8 days. So we could say that 1 by 5 into X is equal to 8. So X is 40 days. So he is able to do that one work in 40 days. Compared to A, B is a very, very low efficient person. A is completing the work in 15 days, whereas B is completing that one work in 40 days. So compared to A, B is going to be a very less efficient person. So I hope how to find this X value is understood by you very, very clearly. So let us proceed. We were in the, yes, this is, I hope these two questions are done. The same example. So let us take, this is a very important and very strong formula. This is also a time saving result, TSR. Please take down this formula. This is not available in any of the books. So this is an example of no, the format is similar to parallel resistance. So 1 by days taken by A plus 1 by days taken by B is equal to 1 by days taken by A and B together. So I'll be explaining the logic behind that formula over here. Okay. So please take down this formula. 1 by days taken by A alone to complete that one work plus 1 by days B takes to complete that one work alone is equal to 1 by days A and B take together to complete that one work. So this can be extended. 1 by D1 plus 1 by D2 plus 1 by D3 is equal to 1 by D. So reciprocal days have to be taken. The summation of the efficiencies. This is the main logic behind this is summation of efficiencies. So that is why I have seen you have written over here as efficiency ratio. So method one is of course just to substitute A and B in the formula and get the AB. That is D1 D2 by D1 plus D2 in case of 2 days. If 3 days are given, you use 1 by D1 plus 1 by D2 plus 1 by D3 equal to 1 by D. So you get the answer. I will coming to the logical method, that is more important. So given that A takes 20 days to complete one work, B takes 30 days to complete one work. Okay, yesterday they have taken the concept of LCM. So 20 and 30, which is the largest number, 30 and 31s are 30, 30 doesn't go by 20, 32s are 60, 60 go by 20. So LCM of 30 and 20 is going to be 60. So you keep the LCM one side. Now we want the efficiency ratio. I had said that all the concept is going to be based on efficiency. So let us take 1 by B, A is to 1 by B because efficiency inversely proportional to number of days. So 1 by 20 is to 1 by 30. Is 30 is to 20 or 3 is to 2. So days ratio is 2 is to 3. Now efficiency ratio is 3 is to 2. Please take the efficiency ratio. Once you take the efficiency ratio, take the total ratio. Total ratio is 5. 3 plus 2 is 5. Now what you do is you have taken LCM now. Take the LCM 60 and divide it by the total ratio. Divide it by total efficiency. Why do we divide it by total efficiency? Because A and B are working together. Efficiencies could be added. It follows a linearity property. We could add the efficiencies. 3 plus 2 is 5. 60 by 5 is 12 days. I hope formula method and logical method, they are matching. Answers are matching. 12 days, 12 days. So let me give another example with the same concept. Of course, I have taken 3 people's capabilities given, and you have to find how many days it will take if all of them work together. So formula method is easy. Just you substitute and simplify, you get the answer. Logical method is you take A is 12 days, B is 15 days, C is 24 days. Take efficiency ratio. 1 by 12 is to 1 by 15 is to 1 by 24. I have skipped some steps due to lack of space. Don't if you're not getting the continuous steps, please do interrupt me and ask me the things. 1 by 12 is to 1 by 15 is to 1 by 24. Upon taking the LCM, what is the LCM of 12, 15 and 24? So upon taking LCM is let us take the greatest number. Yesterday the concept has been discussed. 24. 24 ones are 24 twos are 24 threes are 24 fours are, they won't be divided by 15. 24 fives are 120. 120 is the LCM. Divide throughout by 120 to get the ratio as 10 is to 8 is to 15. Sorry, 10 is to 8 is to 5. Now what is the total ratio? 10 plus 8 plus 5, 23. This is the total efficiency. Now we have taken the LCM of 12, 15 and 24 as 120. As per the concept that has been discussed yesterday. And as mentioned before, the total days taken by ABC to work together is going to be the LCM, that is 120 by total efficiency 23. So formula method you are getting 120 by 123, and logical method also you are getting 120 by 23. In logical method, very simple. Jot on the days, take the efficiency ratio and find the total ratio, that is the total efficiency. Find out the LCM of the 3 numbers 120 and divide it by the total efficiency. 120 by 23 is the total number of days, and you have to convert this to mixed fractions because your options are going to be based on the mixed fractions. I hope this concept is clear. So yes, this is an application of the formula. A can do one work in 12 days. A's capability is 12 days. With the help of B, that doesn't mean B is alone. With the help of B means A and B together. He is doing in 10 days. How many days B is going to do alone? So B is going to be the X. B is going to be the unknown parameter. You want to calculate the B. So 1 by dA plus B is equal to 1 by dA plus 1 by dB. So doing this problem, because the X is going to be B, the efficiency of B is going to be a variable part. So this would be little logically very tricky. It won't strike your mind very quickly. That is why I have given this formula, so that you immediately apply the formula and immediately you just find out the result and just tick the option 60 and go on to the next question. So that is going to be the thing. So 1 by D is equal to 1 by D1 plus 1 by D2. Apply the formula and you get it as 60. I hope the 12th question is also understood. As mentioned before, efficiency is inversely proportional to time. Efficiency is directly proportional to salary. Salary is distributed on the basis of efficiency, not basis of time. I worked for 100 days. I simply sat. For that, they won't give me the salary. But if I work efficiently for 10 days, they will give me that salary. So salary is always based on efficiency, not based on time. You should understand this. This is also very important for real life. Even in an industry, the salary is distributed only on the basis of efficiency, not based on the time you sit and work. So let us see the example. So we are here also, as mentioned before, you have to take the efficiency ratio. I hope taking the efficiency ratio, that step is clear for all. I hope that step is clear for all. Okay. So time ratio is 7 is to 14 is to 21. Efficiency ratio is 1 by 7 is to 1 by 14 is to 1 by 21. Now, what is the LCM of 7, 14, 21? As per the method discussed yesterday, take up the largest number, 21. 21 ones are 21. Does 21 go by 14? No. 21 twos are 42. 42 goes by 7. Yes. 7 6 are 42. 42 goes by 14. 14 twos are 42. Yes. 14 threes are 42. Sorry. Yes. So it is going. So 6 is to 3 is to 2. You are getting the ratio. Efficiency ratio is obtained to be 6 is to 3 is to 2. So 1 by 7 is to 1 by 14 is to 1 by 21. Upon getting the LCM and simplification, you are getting it as 6 is to 3 is to 2. Now, what is the share of A? Now, if I ask what is the share of A? 6 by 6 plus 3 plus 2 into 24. What is the share of B? 3 by 6 plus 3 plus 2 into total 242. Now they have asked in question, what is the share of C? What is the share of C? The share of C is 2 by 11 into 242. 242 is nothing but 11 into 22, and of course 11 11 cancels, 44. So share of C is 44. I hope it is understood. Similarly, share of A and B could also be found. Once you find out 44, just take the option and go on to the next question. I hope this concept is understood. This is actually very important formula that is given to you. This is not present in many of the books. Please take down this formula. This is very much helpful, especially when you're not getting the logic. No, you please apply this formula. Let me explain the logic behind this. This can be extended to many number of people as well. I have given the formula only for A and B. Similarly, that 1 by D is 1 by D1 plus 1 by D2. I gave only for 2 people. Please extend it to many people. Okay. So you please concentrate over here on the RHS part. RHS part is 1. What is this 1? Total work. Unitary method, what we have assumed? We have assumed that total work is 1. So the formula is 1 by how many days that A is going to take to complete the work alone. 1 by this parameter 1 by A. This is said to be the efficiency of A and how many days he worked. Okay, how many days he worked. So that is going to give the parameter A. That is going to give the first part of the addition. Next, 1 by how many days B takes alone to complete one work. So that is going to be the efficiency of B into how many days that guy worked, plus 1 by C, alone work, into how many days he worked. Total plus sigma is equal to 1 because total work is 1. Okay. So 1 by A into how many days A worked plus 1 by B into how many days B worked is equal to 1. So next problem, actually, please work it out. I have given the solution in the next page. I am waiting for solution. Okay. Please jot it down in the chat box. A can complete a work in 12 days. Now, what is the efficiency of A? 1 by 12. Keep it aside. B can do the same work in 15 days. What is the efficiency of B? 1 by 15. So 1 by 12 into something plus 1 by 15 into something is equal to 1. A starts the work. B joins the work 4 days after him and they complete the work together. How many days B works for? So I have written the given data again. A alone 12, B alone 15. Okay, what is the efficiency of A? 1 by 12. What is the efficiency of B? 1 by 15. Okay, so they say that no, A and B they work together, but B has joined 4 days later and they complete the work together. And they are asking X, that is, they are asking B work the days. So if we take B as X, A has worked 4 days before B itself. Before B joining, A has worked 4 days extra. So X plus 4 is for A and X is for B. Now if you take Y for A, what is for B? Y minus 4, because B joined 4 days late. So now we are taking B is the reference. So A should be, we could say, extended. We should say X plus 4, he worked the extra. So now apply the formula. Please take down the formula and apply it. 1 by A alone, that is his efficiency, into how many days he worked, plus 1 by B alone, that is his efficiency, into how many days he worked, is equal to 1. So 1 by 12 is the efficiency of A, into how many days he worked, X plus 4, plus 1 by 15 is the efficiency of B, how many days he worked, X, add is equal to 1. 1 is why are we taking 1? We are taking 1 because uh, 1 is the total efficiency, total work done. And similarly, this is also covered in +2 probability. This is also known as total probability theorem. So this is also covered in probability. This is also covered in time and work. This is known as unitary method in time and work. This is known as total probability theorem in your +2 probability, where total probability is 1. And 1 by efficiency into how many A plus efficiency of B into how much worked by B is equal to 1. So upon substituting, upon simplification, you get it as 40 by 9 or 4 by 9 days. Pipes and systems. I could complete this in the short method. Actually, they have just mentioned this. The positive efficiency for inflow and negative efficiency for outflow. Now, what is this cistern means? What do you mean by pipe? Cistern is nothing but a drum. Okay, it is going to be a drum. Okay, and one pipe is going to bring the water in. Another pipe is going to take the water out of the cistern. So that is going to be the concept. Sometimes what happens because of lack of engineering or because of the time, because of you could say wear and tear in that system, there is going to be a crack, there is going to be a leak. Plumbing works need to be done, but plumbing work is not done, and water starts dripping out. And because of that, we need to calculate efficiency of the boiler, and we need to calculate the efficiency of the cistern or such things that are very, very important. Let me discuss. So now we have taken now. So in the previous example, what is A's work? A completes that one work in 12 days. B completes the one work in 15 days. What is the efficiency of A? 1 by 12. What is efficiency of B? 1 by 15. Now in pipes and cisterns, they will not give in days, they will give in hours. You could see pipe A fills the empty cistern. Or the cistern is empty. They are going to fill the water. They are going to fill the water with the help of an external tanker. See, that guy, that pipe A, he can fill the empty cistern in 12 hours. Pipe B can empty the cistern. One cistern is fully filled, he has to empty, because some poison may be filled in that cistern. You have to empty the water and you have to throw the water. So, or sometimes because of flooding, especially in Chennai and all, it is very much common. There is a flood, you bring a motor, okay, and the motor, the suction motor, what it does is it sucks the water. So we know the efficiency of motor. That is in electrical engineering, output power by input power. Anyway, taking this is the time and work concept. So here, inflow time, the water inflow time is said to be the positive efficiency. Outflow time is negative efficiency. Let us see the example over here. Pipe A fills the empty cistern in 12 hours. What is the efficiency of pipe A? Pipe A fills a cistern in 12 hours, means the efficiency of A is 1 by 12. Pipe B empties a cistern in 15 hours. In previous chapter, what you used to do, we used to take it as 1 by 15. Here nothing, just to take it as minus 1 by 15. That's the thing. Now you take the efficiency ratio 1 by 12 is to minus 1 by 15. Upon taking the LCM of 12 and 15, take the largest number 15, and 15 ones are 15 twos are 15 threes are 15 fours are 60. 60 is divisible by both of them. 60 is the LCM. Multiply by 60. So you get the ratio as 5:4. Okay, so there what we used to do, we used to calculate the total ratio. How we used to calculate the total ratio? 5 plus 4 is 9. Here what is to be done? 5 minus 4 is 1. Okay, so that is the concept. Negative efficiency concept is nothing but you are just jumping from chapter number the previous chapter to the pipes and cisterns. So it is nothing new. It is just an application of time and work, a negative efficiency concept. Now what is the efficiency LCM of 12 and 15? We calculate it to be 60. Now, what is the thing? Time taken to fill is going to be 60 LCM by total efficiency 1, 60 by 1, 60 hours. Why is it taken to be negative efficiency? Does anybody know? Because A is trying to do something positively. He is trying to fill the water. B is emptying. He is doing negative work. That is why his efficiency is negative. So everything is explained very clearly. So that is why we are taking negative efficiency. That is why 5 minus 4 is 1. So that is why we take 60 minus 1 is equal to 60. So that is why the total efficiency is subtracted, not added. Okay. The total time taken to fill the tank is 60. Okay, the pipe A can actually fill it in 12 hours, but because of this pipe B, it is a problematic situation. He is taking 60 hours. So hope this is understood. Let me give you another problem to work out. Okay, pipe A. Okay, this is the example of engineering defect. There is a leak present there. Okay, pipe A is 6 hours it takes to completely fill the tank. Now there is one leak or one crack that is present. Due to the leak, it takes 9 hours to fill the tank. Okay, because of leak, some water comes out automatically and it is going to be wasted. Okay, so we are not concerned about the water wasted. We are not concerned about the volume of the water wasted. We just want the time. Due to the leak, it takes 9 hours, 3 hours more it is taking to fill the tank. In what time? The leak alone can empty the full tank. Now what are they have asked? They have asked that, okay, they have asked that, now you imagine that there is no pipe A filling. You imagine that there is only one pipe B. Okay, and that is not a pipe B, that is a leakage B. So with the help of that crack, you can empty that entire tank in how many hours? That is what they are asking. So what is to be done is, you use the formula over here mentioned there. What is the formula? 1 by D is equal to 1 by D1 plus 1 by D2. Now here it is time, it is not days. Okay, 1 by total time taken for pipe plus leak is equal to 1 by pipe plus 1 by leak. So what is pipe plus leak? They have given us 9 hours to fill the tank, positive. What is the pipe? Pipe is also 6 hours. That is also positive. So 1 by 9 is equal to 1 by 6 plus 1 by leak. So upon some simplification, we get it as minus 18. Now what does this negative sign simplify? Oh, sorry, signify. What does this negative sign signify? Negative sign signifies that there is going to be a negative efficiency. Negative efficiency means leakage. So the leakage alone takes 18 hours. So if you don't keep any pipe and the cistern is fully filled with that crack in 18 hours, if you come and see, there would be no water. Everything would be outside. So this is the concept. Same formula, the efficiency should be taken in the negative way. That's it. If there is a filling, there should be a positive efficiency. If there is a leakage, there should be a negative efficiency. Hope it is understood to all. This time and work, the unitary method concept, and this pipes and cistern concept is understood to all. Okay. So this is all about time and work concept. Okay, we have covered about the first part, that is going to be the chain rule, that is M1 D1 H1 by W1 is equal to M2 D2 H2 by W2. Then the Mandate's concept, M1 D1 is equal to M2 D2. Then we saw the unitary method, that is the total unitary work. The total work is always going to be 1. Then applications of that is nothing but the pipes and cisterns. Okay. So these are very, very important problems. I would like to thank the Leo Club of CEG and the event team. That is the name of the team is the Quants. So I would like to thank them for giving me this wonderful opportunity to share my small amount of knowledge with all of you, so that we could improve together, and we could also, we could improve together to create a better society. So Leo Club always tends to do good activities for the benefit and welfare of the club members as well as for others as well. So this activity is proven to be a very great activity that has been proven to enhance the quantitative aptitude of all. Hope the time and work concept is clear for all. Any doubts you could ask me now. If there are no doubts, we could complete the session. Thank you all.